Okay, here we have this knockoff Makita battery, or should I say compatible Makita battery. Now these are available on eBay pretty cheaply, and it's a bit hit and miss as to whether you get a good deal or not. Some are okay and some are just terrible. This one lasted about 2 months before it failed, and of course taking anything back to China is a real pain. Basically you plug it onto the charger and it'll just beep at you and say the battery's faulty and not charge the battery. And when you press the power button, it flashes, but it should stay solid to display how much charge the battery has. Obviously it's got nothing. So let's look at this battery then. We've got some general 18650s as they usually are, which are sort of spot welded together, not particularly well with this steel. It's not actually nickel, it is steel, I have confirmed that. It rusts quite badly, the other battery had all corroded inside. But as far as actually switching output protection goes, say if you shorted this battery, it's got some charging protection. I don't know if you can see the charging circuitry side of things. And it's got a temperature sensor, but there doesn't appear to be any kind of FET on here that switches the bloody thing off. Should the thing short out or anything like that happens. There's also only 2 wires. Okay, no, there's 3 wires, so you've got like a centre tap going to this BMS. It's not balancing each individual bank of cells. You know, each individual parallel line of cells would normally have its own, you know, balance lead coming off of it, but that doesn't appear to be the case here. So you've got this one here. Let's have a look at this. This is our first light string. So these 2 cells are wired in parallel. Then this next string of cells is wired in parallel. It's a 5S2P pack. There's no balance leads on there, so it doesn't know where it is in terms of how balanced the battery is at all. So, you know, with drift over time, you could have this cell here be 3 volts, and this cell here could be 4.3, which of course would mean it's in an overcharge situation, and you could have a fire on your hands. Right, the cells themselves, this is the other dodgy bit, are the LG. Now, I might be wrong on this, but I'm pretty sure this bottom number here is irrelevant. I couldn't find anything for this bottom number or this number all typed in. I could only find information for the top number. That top number is LG DAHA11865. The bottom number, for those who maybe can't see it, and are going to try and dig up more info, is N069C105A4. Anyway, here's the data sheet for these things. Sorry, there's no screen capture or fancy editing or anything like that. So this battery was advertised as a 5 amp hour, and as you can see it's 1300 milliamps per cell, so that would make it 2.6 amp hours. 3.7 volts, 1.2 amps, you know, standard charge current, max charge current 2.2 amps. Well, we'll do some fast charging, I suppose. Max pulse current, max continuous discharge current. Get a bit closer to that so you can read it, 'cause it's pretty shocking. 2.4 amps is the maximum continuous discharge current. Max pulse discharge current 4.8 amps. These are batteries used in power tools. Makita in particular, these are professional grade power tools, and you're driving them with a battery that can only put out 4.8 amps. Pulse current. Okay, so 2 batteries, that's going to be near enough 10 amps, you know, so it's going to be 9 point, yeah. That's only pulse currents. This battery is going to be running right at its limit, or these cells are going to be running right at their limit all the time. Well, you know, just over their limit really, because that's the pulse rating, it's not even the full continuous rating. So on a multi-tool or something like that pulls a lot of power, you're going to destroy this battery pretty quickly and even risk fire or explosion. So that's pretty shocking. The fact it didn't have any balance leads coming off and the BMS is just basically there to fudge the charger into getting the thing to work is another thing. I wonder why it actually tripped the charger. The cells are, you know, they're relatively close to the voltages, they should be, but it will not charge. So I can only assume that it's overheated, this like sensor's shorted out or something like that, although it isn't throwing overheat code. it's just refusing to charge the battery. So the only thing I could assume is that the actual circuitry on here that's telling the charge of the battery is present is faulty, and the battery is not actually communicating with the charger properly, and that's why it died. Not that there's any loss, because if it continued working it could have burnt the bloody house down. Gone bad, cells gone bad and burnt the house down. But the only other thing I can think of is it's measuring the resistance of the battery, like its internal resistance on the charger, and then the charger's saying, nope, I ain't charging that. That concludes this video of the fake Makita battery. I did have two of these. One was quite badly corroded, and I just pulled this set out for demonstration purposes. It's the same one that is in this battery. That concludes this video. See you later.